Okay, I would like to go over homework 1.3, number 7, part B. Alright, so first thing we need to do is we have to come up with a formula for g of f. And this notation just simply means that g of f of x, right? So we just have to plug in f of x into the g function. Alright, so let's do that. So we have to work from inside out. So f of x is x plus 1 over x. So we have that. Alright, then now whenever you see x here, we're going to put x plus 1 over x. And whenever you see x here, we're going to put x plus 1 over x. So this is going to be, so replacing those x's by x plus 1 over x, you're going to get x plus 1 over x plus 17 on top. Then you have x plus 1 over x plus 2 on the bottom. All right. And you can probably leave it like this, but most of the time we'd like not to have fractions inside a fraction. So I'm gonna try to multiply top and bottom by x. Right? As long as you're multiplying top and bottom by the same thing, the quantity will stay the same. Right? So you're gonna have x times x. So x times x is going to be x squared, right? Then x times 1 over x will give you 1. So I'll put plus 1 here, and to make it look a little bit nicer. And 17 times x. So you're going to have plus 17 times x, right? All over, right? X times x again. So x squared. And x times 1 over x is plus 1, right? And x times 2 will give you 2x, right? So if you want, you can factor out the bottom so it looks nice. Maybe I should do that. You will get something like this. X plus 1 quantity squared. Then you have x squared plus 17x plus 1. All right, so that's the formula for g of f of x. All right, then the next thing we need to do is find the domain of g of f. So we have to find the g of f and the domain of f and domain of g separately first. So domain of f in this case, right? So here, domain of f, only bad number would be, having a 0 on the bottom. So everything other than 0. So it's all real numbers except for 0 would be the domain of f. Domain of g would be similarly, but when x equals -2, denominator becomes 0, so we have to exclude -2. So domain of g is all real numbers except for 2. Oh, sorry, -2. So -2 to infinity. All right, now we can find the domain of g of f. So domain of, say, g of f is going to be, remember that domain of g of f, x has to be at least in the domain of f. So it has to be in domain of f. Then at the same time, we have to make sure that the f of x is in the domain of g. So f of x is in the domain of G, right? But what does that mean, right? So let's look at this part. So X is in domain of F, right? That simply means that X has to be in here, which means that X cannot be equal to 0. So 0 is excluded from there, from the domain. All right, and what does this guy mean? All right, so this means that the f of x has to be in the domain of G, which is all real numbers except for -2. So this just means that the f of x cannot be equal to -2. All right, so let's think about when f of x becomes -2. All right, so f of x is x plus 1 over x, right? Then we don't want this guy to be -2, right? All right, so to make this equation a little simpler, again, I don't like fraction, so multiply both sides by x. So we get x squared plus 1 cannot be equal to -2x, right? Then we can add 2x to both sides to get x squared plus, I rearrange it a little bit, 2x plus 1 cannot be equal to 0, right? Then we can complete the square or factor out. So this is same thing as x plus 1 quantity squared cannot be equal to 0, right? Which means that x cannot be equal to -1, because if it's -1 it becomes 0, right? So we have that. All right, so this guy actually boiled down to x cannot be equal to -1, and we originally had x cannot be equal to 0. So the domain of G of f, so domain of G of f is going to be all real numbers except for 0 and -1. So we should probably write it as, maybe I need a little bit more room. So we should write it as -infinity to -1, skip -1, skip -1, and go all the way to 0, skip 0, and go to positive infinity. Right, so this is the domain of the composite function g of f. I hope this was clear.